In today's video lecture, your concepts on terminating and non-terminating, repeating, decimal expansions will be cleared. So first we'll discuss all the theorems and then we'll discuss about the various problems on the terminating and non-terminating repeating decimal. So the first theorem states that if you consider a irrational number is there, p by q, and you're equating that to x, okay, then that decimal expansion of x is terminating, for example. Then that x can be expressed in the form of p by q, where p and q are co-prime, and prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. It means that, for example, you have a rational number and that rational number terminates. Then that terminating decimal expansion can again be represented in the form of rational number. And that denominator q, it can be expressed in the form of 2 power n into 5 power m. So terminating means it is of the form 2 power n into 5 power m. Now let us see one problem. The question is express the following decimal in the form of p by q and write the denominators in 2 power n 5 power m form. So we are having 0.25. We know 0.25 is terminating. How can we say that 0.25 is terminating? Because we don't have any other numbers after 25. It is stopping here only. Okay, that is why 0.25 is terminating. Now if I want to convert this decimal to rational number, that is p by q form, what can I do? How many decimal places are there after decimal point? 1, 2. So I can multiply with 100 since there are 2 decimal places. So 0.25 into 100. Whatever I am multiplying in numerator, the same thing I have to divide in denominator. So 0.25 into 100 by 100. Now how to remove these decimal points? These two zeros will be used to remove this decimal point. That is 1, 2. So 0.25 into 100 will become 25 divided by 100. Now these both will go in 5 table. 5 5s are 25, 5 2s are 10, 5 zeros are 0, and then again 5 1s are 5, 5 4s are 20. So you're left with 1 by 4. But what is our theorem? Our theorem states that the denominator q should be of the form 2 power n into 5 power m if it is a terminating decimal expansion. And also in the question it is telling me to write in the form of 2 power n into 5 power m. So if I expand this 4 in prime factorization, 2 2s are 4, 2 1s are 2, I'm getting 2 square. So denominator can be written as 2 square. Now this 2 square can be compared to 2 power n into 5 power m form. This is 2 power n. So from the theorem you should be clear that if the denominator can be expressed either in the form of 2 power n or 5 power m or both 2 power n and 5 power m, then the decimal expansion is terminating. Even if it's only 2, then also it is terminating. Remember that. Okay, I'm not getting into 5 here, but still it is terminating. Now we'll move to the next theorem. The next theorem states that if x is equals to p by q is a rational number such that the prime factorization of q is of the form 2 power n into 5 power m. There is already the prime factorization of q. Denominator is 2 power n into 5 power m. Then the x has the decimal expansion which terminates. What was the first theorem? The first theorem was that if the decimal expansion is terminating, if the decimal expansion is terminating, then we can write in the form of 2 power n into 5 power m. This theorem is if the decimal expansion of q is of 2 power n into 5 power m form, then it will be terminating. So let us see a problem on it. See, the question is without actually performing division, state whether the following has a terminating expansion or non-terminating repeating decimal expansion. So here I have underlined these keywords. I said whenever you solve questions, underline the keywords. So here we have 1600 is the denominator. So find the prime factorization. Why? Because 15 and 1600 would simplify. So simply I am finding the prime factorization of 1600. 2 8s are 16, 2 zeros are 0, 2 zeros are 0, 2 4s are 8, 2 zeros are 0, 2 zeros are 0, 2 2s are 4, 2 zeros are 0, 2 zeros are 0, 2 1s are 2, 2 zeros are 0, 2 zeros are 0, 2 5s are 10, 2 zeros are 2 2s are 4, 1 0, 2 5s are 10, 5 5s are 25, 5 1s are 5. So I'm having 2 power 6 here and here I'm having 5 square. So this 1600 can be written in the form of 2 power 6 into 5 square. My theorem is whenever denominator can be expressed in the form of 2 power n into 5 power m, then decimal expansion is terminating. Okay. So since it is 2 power n into 5 power m, decimal expansion is terminating. Okay, now the last theorem is that x is equals to p by q be a rational number such that the prime factorization of q is not of the form 2 power n into 5 power m. Now you should be careful here. If the prime factorization of q is not of the form 2 power n into 5 power m, then the decimal expansion will be non-terminating repeating. So it's not terminating. If it is not of the form, then it is non-terminating repeating. Now let us see problems based on this. The question is without actually performing division, state whether the following has a terminating expansion or non-terminating repeating decimal expansion. The question is 64 by 455. Again see the denominator here. What is the denominator? 455. This is 5. This is 4 in one's place. So we cannot divide this. So I'm taking the prime factorization of 455. So since 5 is present here, it will go in 5 table. 5 9s are 45, 5 1s are 5. And here I have 1, so I will try with 7 table. 7 1s are 7, 9 minus 7 is 2, 1. 7 3s are 21. Now 13 is a prime number, so 13 1s are 13. So 455 can be written as 5 into 7 into 13. Now what is the tip here? Since denominator q contains 7 and 13 along with 5. See, 7 and 13 are there now with along with 5. So it is not of the form 2 pi n into 5 pi n. What is the 2 pi n into 5 pi m form? It means that only 2 pi n or 5 pi m or both 2 pi n and 5 pi m. But here along with 5 I have 7 and 13. So it is not terminating. That is, it is not of the form 2 power n into 5 power m.
In today's video lecture, we will be solving all these sums of exercise 1.3 of TS, AP and any other state board and also CBSE. So the exercise is based on the concept of terminating and non-terminating repeating decimal expansion. So this is the exercise. All 4 questions will be solving. Let us do this question. What is this question? It is telling, first question, write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating. Since in this question they didn't say whether we have to use the theorem or not, we can find out whether it is terminating or non-terminating with the help of division. Since there is a fraction p by q, we can divide this and we can find out whether the decimal expansion is terminating or non-terminating. Okay, so first bit is 3 by 8. How can we write 3 by 8 as 3 by 8 can be written as 8 outside, 3 inside. So we can write this as 8 zeros are 0, 3 minus 0 is 3, put a point, bring down 0, 8 3s are 24, okay, this will become 2, this will become 10, 10 minus 4 is 6, take a 0, 8 7s are 56, this will become 5, this will become 10, 10 minus 6 is 4, take a 0, 8 5s are 40. Since we got the remainder 0, we can say that it has a terminating decimal expansion. So what will you write over here? Since the remainder is 0, since the remainder is 0, therefore 3 by 8 is terminating. Or you can write 3 by 8 has a terminating decimal expansion. Since the remainder is 0, 3 by 8 is terminating, or you can write 3 by 8 has a terminating decimal expansion. Moving to the second bit. What is it saying? You have to convert this 229 by 400 in the decimal expansion form. How to convert? Remember, you have 2 zeros here. So first we can remove these 2 zeros. How to remove these 2 zeros? This can be written as 229 by 4. Since it has 2 zeros in denominator, whenever division is there, then you have to shift the decimal point by how many places the zeros are there. I mean that here you have division, right, and here you have 2 zeros. So shift it by 2 places on left side. So 1, 2. So where will the decimal point come now? Here, 2.29 by 4. Remember, whenever you want to remove the zeros from the denominator, shift the decimal point by left side. So here 2 zeros are there. So 1, 2. So it became 2.29 by 4. Now divide this. 4 will be outside, 2.29 will be inside, 4 zeros are 0, 2 minus 0 is 2, okay. Here you have point, take this 2 down, 4 5s are 20, 2 minus 0 is 2, take 9 down, 4 7s are 28, 9 minus 8 is 1, take a 0, 4 2s are 8, 10 minus 8 is 2, take a 0, 4 5s are 20. So now we got the remainder as 0. Okay, so we got 229 by 400 is 0.5725. Since 400 was a very big number, I had removed these 2 zeros and made it to be written as 2.29 by 4, and then by dividing I got the decimal expansion as 0.5725. So now also we can say, since the remainder is 0, therefore 229 by 400 has a terminating decimal expansion. Okay, terminating decimal expansion. Moving on to third bit here. In third bit, we have to convert 4 1 by 5. So this is mixed fraction, right? Convert this mixed fraction into improper fraction first. How to convert mixed fraction into improper fraction? 5 into 4 plus 1. So 5 4s are 20, 20 plus 1 is 21. So this can be written as 21 by 5. So I have converted mixed fraction into improper fraction. Now divide 5 outside, 21 inside. 5 4s are 20, 1 minus 0 is 1. Put a point, bring down 0. 5 2s are 10. Now we have got the remainder as 0. So since again we can write since the remainder is 0, therefore 4 1 by 5 that is also equal to 21 by 5 has a terminating decimal expansion. Remember, whenever remainder becomes 0, the decimal expansion becomes terminating. Okay, next fourth bit is you have to find out whether 2 by 11 has a terminating decimal expansion or not. So same thing, divided 11 outside, 2 inside. 11 zeros are 0, 2 minus 0 is 2, put a point, bring down 0. 11 ones are 11, this will become 1, this will become 10, 10 minus 1 is 9, take a 0, 11 eights are 88, this will become 8, this will become 10, 10 minus 8 is 2, take a 0, 11 ones are 11, this will become 1, this will become 10, 10 minus 1 9, take a 0, 11 eights are 88. So we observe that we are getting the same numbers, see 90 90, right, 11 11, and we are getting 18 18, and we are not getting the remainder as 0. So we get to know that even if we do continue doing the division, we will never get remainder as 0 because the digits are repeating. So here we can say that since the given rational number does not have a remainder 0, it is non-terminating repeating. Since the remainder is not 0, therefore 2 by 11 has a non-terminating recurring decimal expansion. Recurring means repeating, remember it. Okay, in fifth bit it is asking you to find out whether 8 by 125 is terminating or non-terminating. Here we don't have any zeros, so no choice, we cannot remove any zeros. Directly we have to take 125 only and do. So for that I'll give you a suggestion. Write the table of 125, okay, and see what you will get. As 125 zeros are 0, okay, 8 minus 0 is 8, put a point, bring down 0, 125 zeros are 0, 80 minus 0 you will get 80, so take a 0 again. Now see what is 125, 6 are 5 6 are 30, 6 2s are 12, 125 6 are 5 6 are 30, 6 2s are 12, 12 plus 3 is 15, 6 1s are 6, 6 plus 1 is 7, 750 we are getting, right? And if we do 125 7s are, we'll get more than 800. So 125 6 are 750. This will become 7, this will become 10, this will become 9. No, this is 10 only. 0 as it is, 10 minus 5 is 5. Now again take a 0. So if we know that 25 4s are 100. Similarly, find out what is 125 4s are. 5 4s are 20. 4 2s are 8. 8 plus 2 is 10. 8 plus 2 is 10. 4 1s are 4. 4 plus 1 is 5. 500. So 125 4s are 500. 500 minus 500 is 0. So again here we can write, since the remainder is 0, (8 by 125) has a terminating decimal terminating decimal expansion. Okay, since the remainder is 0, 8 by 125 has a terminating decimal expansion. Hope you are understanding. So remember, in the first question, it did not ask us to without performing division. It didn't tell us like that. That's why we have divided, and we are seeing it whether it is terminating or non-terminating. How to find whether it is terminating or non-terminating? If the remainder is 0, it will have terminating decimal expansion. Suppose if the remainder is 0 and the number goes on repeating, then it will have non-terminating repeating decimal expansion. This is how you find out with the help of division. Next question is, here it is telling us, see, without performing division, state whether the following rational numbers will have a terminating decimal form or non-terminating repeating decimal form. So here it is clearly telling us without performing division. Means you have to use the theorems which we have discussed. Okay. 13 by 3125. Okay. So how to do this? You have to take out the prime factorization of 3125. So 3125, here the units place is 5, so we can use 5 table. 5 6 are 30, 1 minus 0 is 1 2, 5 2s are 10, 2 5, 5 5s are 25. 5 1s are 5, 6 minus 5 is 1 2, 5 2s are 10, 2 5, 5 5s are 25. Again with 5, 5 2s are 10, 2 minus 0 is 2 5, 5 5s are 25, 5 5s are 25, 5 1s are 5. So we can write 3125 as 5 times 1 2 3 4 5. So 13 by 3125 can be written as 5 into 5 into 5 into 5. So what is this? This can be expressed in the form of P by Q, right? So we know that whenever a rational number can be expressed in the form of and that is Q, if it is expressed in the form of 2 power n into 5 power m, we can say that the given rational number has a terminating decimal expansion. So here if you observe, we have 5 power 5 and also we have 2 power 0. We can write this as 13 by 2 power 0 into 5 power 5. Why 5 power 5? Because 5 is 5 times. So we know that we can express Q in the form of 2 power n into 5 power m. Therefore 13 by 3125 is terminating. Q can be expressed in the form of 2 power n into 5 power m. Therefore 13 by 3125 is terminating. Okay. Similarly, find out 11 by 12. We know 12 can be written as 2 6 are 12. So 2 into 6. How can we write 6 as? 2 into 3. So 12 is 2 into 2 into 3. If you do prime factorization, also you will get the same answer. Now here if you observe in this question, we don't have any 5. Do we have any 5? We don't have any 5. Whenever this Q, that is denominator, will have either 2 or 5 or both 2 and 5, then only it will be terminating decimal expansion according to the theorems which we have studied. But here we have 3 also along with 2, so this becomes non-terminating. So here what we will write? Here Q is not of the form of 2 power n into 5 power m. Since what is Q here? 2 square into 3. Therefore 11 by 12 has a non-terminating recurring means repeating decimal expansion. Okay, it is 64 by 455. So find out the prime factorization of 455. 5 9s are 45, 5 1s are 5, 7 1s are 7, 9 minus 7 is 2 1, 7 3s are 21. And 13 1s are 13 we have. So we can write 455 as 5 into 7 into 13. So again, as along with 5 we also have 7 and 13. Therefore this is of the form of P by Q. This Q, that is denominator, it is not having only 2 and 5 or only 5 or only 2. It is having also 7 and 13 along with 5. So we say that it is Q is not of the form of 2 power n into 5 power m. Therefore 64 by 455 has a non-terminating recurring decimal expansion. Okay, moving on to fourth bit, 15 by 16,000. How can we write 16,000 as? Find out the prime factorization of 16,000. 2 it will go, because here we have a unit place is 0, 2 8s are 16, 2 zeros are 2 zeros are 2 zeros are 2 4s are 8, 2 zeros are 2 zeros are 2 zeros are 2 2s are 4, 2 zeros are zeros are zeros are 2 thousands are, then we have 2 5s are, then again with 2 2 2s are 4, 5 minus 4 is 1 0, 2 5s are, again with 2 2 1s are 2, 2 2s are 4, 5 minus 4 is 1 0, 2 5s are 10. Now it is will go in 5 table, because units place is 5, 5 5 2s are 10 we have, and 2 5, so 5 5s are 25, 5 5s are 5 1s are. Now if you observe, this will become 15 by, how can you write 16,000 as? How many 2s are there? 1 2 3 4 5 6 7, 2 power 7 into how many 5s are there? 1 2 3. So since we can equate this to rational form p by q, so q is in the form of 2 power n into 5 power m. Since q is equals to 2 power n into 5 power m, therefore 15 by 16,000 has a terminating decimal expansion. Okay, fifth bit, 29 by 343. We know 343 is nothing but 7 cube. I know the prime factorization of 343. It is nothing but it is 7 into 7 into 7. That is 7 cube. So we can write 29 as 20. We can write 343 as 7 cube. Right. So does it have 2 in denominator? No. Does it have 5 in denominator? No. Does it have both 2 and 5 in denominator? No. So since q is not of the form of 2 power n into 5 power m, therefore 29 by 7 cube is non-terminating recurring. Sixth bit, 23 by 2 cube into 5 square. Directly it gave us in the form of 2 power n into 5 power m. So we can write 23 by 2 cube into 5 square is equals to p by q, where q is equals to 2 power n into 5 power m. Therefore 23 by 2 cube into 5 square has a terminating decimal expansion. Okay, seventh bit, 129 by 2 cube into 5 power 7 into 7 power 5. Now here if you observe, 2 is there, 5 is there, but along with 2 and 5 you also have 7, so it will not be terminating. Remember, even if we have one number extra along with 2 and 5, then it will be non-terminating, repeating. So we can write, since q is not of the form of 2 power n into 5 power m, therefore 129 by 2 cube into 5 power 7 into 7 power 5 is what? Non-terminating repeating or non-terminating recurring. Okay, 9 by 15. How can you write 15 as? 3 5s are 15. Along with 5 we also have 3. So will it be terminating or non-terminating? It will be non-terminating. Since what can we write? Q is equals to 3 into 5, which is not equal to 2 power n into 5 power m. Therefore 9 by 15 is also non-terminating repeating or non-terminating recurring. 36 by 100. So we know 5 2s are 10, right? And what can you write 100 as? Take out the prime factorization. 2 5s are 10, 2 zeros are 2 2s are 4, 5 minus 4 is 1 0, 2 2s are 4, yeah 1 0, 2 5s are 10, 5 5s are 5 1s are. So we can write 100 as 2 square into 5 square. So since q, that is denominator, is of the form of 2 power n into 5 power m, therefore 36 by 100 is terminating. 10th bit 77 by 210. Okay, so this can be written as C210. How can I write 210 as 3 7s are 21, 3 zeros are 0, 7 10s are 70, 2 5s are 10, 5 1s are 5. That is, we can write 210 as 3 into 7 into 2 into 5. That is also equal to P by Q. So we can write, therefore, since Q is equals to 3 into 7 into 2 into 5. But is it of the form of 2 power n into 5 power m? No, it is not of the form of 2 power n into 5 power m. Since we also have 3 and 7 along with 2 and 5. So we can say it is not equal to 2 power n into 5 power m. Therefore, 77 by 210 is non-terminating recurring. Third question is, write the following rationals in decimal form using theorem 1.4. See, this is theorem 1.4. Let x is equals to p by q be a rational number such that the prime factorization of q is of the form of 2 power n into 5 power m. That is, the denominator q, it is of the form of 2 power n into 5 power m, and m are non-negative integers here. Then x will have a terminating decimal expansion. So using this theorem, we have to do the third question. If q is 2 power n into 5 power m form, then it will have terminating decimal expansion. Okay. So how to do this kind of sum? See carefully. 13 by, how can we write 25 as 5 square? So whatever is there in denominator, power of 5, same thing you have to multiply in numerator as well as denominator. So here we have power 2, right, for 5. So here you should multiply and divide with power 2. Okay, now how can we write this as? We can write this as 13 into, just open the numerator, मतलब आप 2 स्क्वायर को 4 लिखेंगे, लेकिन आप और डिनोमिनेटर को भी ओपन करिए. 5 स्क्वायर 25 है, ठीक है. ये 2 स्क्वायर है ना, सॉरी, नॉट 5 स्क्वायर, बिकॉज ये वॉट एवर वी आर मल्टीप्लाइंग इन न्यूमरेटर, सेम थिंग वी हैव टू मल्टीप्लाई इन डिनोमिनेटर ऑल्सो. 2 स्क्वायर क्या है यहाँ पे? 4 है. तो हम लोग इसको लिख सकते हैं, व्हाट इज 13 4 52 बाई 25 4 अगर आप डिवाइड करें तो आपको आएगा 100. कभी भी अगर डिनोमिनेटर में जीरोस आ गए, मतलब मैं इसको डेसिमल फॉर्म में लिख सकती. कैसा? अब भी बोली थी मैं आप लोगों को, डिवाइडेड बाय 100 अगर रहा तो शिफ्ट इट बाय 2 प्लेसेस, बिकॉज वी आर हैविंग 2 zeros ऑन द लेफ्ट साइड. डिवीजन में लेफ्ट साइड शिफ्ट करते हैं, मल्टीप्लीकेशन में राइट साइड शिफ्ट करते हैं. यहाँ पर डिवीजन है ना, तो शिफ्टेड बाय लेफ्ट साइड 1 2, तो ये क्या बन जाता है? 0.52. तो वो बोला था मुझे ये फ्रैक्शंस को डेसिमल फॉर्म में लिखना है, मैंने ये फ्रैक्शंस को डेसिमल फॉर्म में लिख दिया. ठीक है. अब देखिए 15 बाई 16 को 15 बाई 16 के अंदर रिटर्न है. सबसे पहले आप 16 का प्राइम फैक्टराइजेशन निकालिए, आपको 2 पावर 4 आता. क्यों? क्योंकि आपको मालूम 2 क्यूब 8 होता और 2 पावर 4 16 होता. मतलब 2 इंटू 2 इंटू 2 इंटू 2, 2 4 टाइम्स इज कॉल्ड एज 16. तो मैं इंस्टेड ऑफ डूइंग द प्राइम फैक्टराइजेशन ऑफ 16 आई ऑलरेडी न्यू, सो मैं डायरेक्टली लिख दी. अगर आप लोग को नहीं मालूम तो आप लोग करके देखिए. देखिए 2 8 जा, 2 4 जा, 2 2 जा, 2 1 जा, आप लोग को मिला 16 2 पावर 4. ठीक है, 2 4 टाइम्स. अब क्या करना, जो भी पावर है 2 का, सेम थिंग आप न्यूमरेटर में भी और डिनोमिनेटर में मल्टीप्लाई करेंगे. यहाँ पर अगर 2 है तो हम लोगों को किससे मल्टीप्लाई डिवाइड करना है? 5 पावर 4 बाय 5 पावर 4. क्या करना? 15 इंटू व्हाट इज 5 पावर 4? 5 पावर 4 625 होता है. कैसा? बिकॉज हम लोग को मालूम 5 5 25, 25 5 125. हम लोग 125 5 करके देखेंगे. 5 5 25, 5 2 10, 10 प्लस 2 इज 12, 5 1 5, 5 प्लस 1 इज 6, 625. तो 5 पावर 4 क्या हो गया? 625 है. अब 2 पावर 4 क्या है? हम लोग को मालूम 2 पावर 4 इज 16 एंड 5 पावर 4 इज 625. ठीक है, तो आपके पास अब मल्टीप्लाई करिए. व्हाट इज 625 इंटू 15 करके देखिए आप. यहाँ पे करूँगी मैं 625 इंटू 15. 5 5 25, 5 2 10, 10 प्लस 2 इज 12, 5 6 30, 30 प्लस 1 इज 31, 1 5 5, 1 2 2, 1 6 6, 5 5 प्लस 2 इज 7, 2 प्लस 1 इज 3, 6 प्लस 3 इज 9, 9375 मेरा हम लोग को 625 इंटू 15 का आंसर. तो यहाँ पर मैं लिख दूंगी 9375. अब हम लोग को मल्टीप्लाई करके देखना है 625 इंटू 16 क्या आता. 625 इंटू 16, 5 6 30, 6 2 12, 12 plus 3 is 15, 6 6 36, 36 plus 1 is 37, 1 5 5, 1 2 2, 1 6 6, 0, 5 plus 5 is 10, 7 plus 2 is 9, 9 plus 1 is 10, 6 plus 3 is 9, 9 plus 1 is 10. मतलब हम लोग कितने जीरोज आए? 4 जीरोज आए. 1 2 3 4. तो मैं इसको क्या लिख सकती? 16 इंटू 625 को 10,000. अब यहाँ पर फिर से हम लोग के पास जीरोज है डिनोमिनेटर में, तो हम लोग इसको डेसिमल फॉर्म में लिख सकते हैं। 4 जीरोज है तो कितने प्लेसेस में शिफ्ट करना है हम लोग को लेफ्ट साइड, 4 प्लेसेस, बिकॉज 4 जीरोज है, 1 2 3 4, तो हम लोग इसको कैसे लिख सकते हैं, 0.9375। ठीक है, आई होप यूर अंडरस्टैंडिंग कैसा हम लोग थ्योरम 1.4 को यूज़ करके कन्वर्ट करके इसको डेसिमल फॉर्म में लिख रहे हैं। फर्स्ट क्वेश्चन भी अलग था, सेकंड क्वेश्चन भी अलग है, थर्ड क्वेश्चन भी अलग है। ठीक है, केयरफुली अगर आप लोग को समझ में नहीं आ रहा तो पॉज करिए, स्लो करिए स्पीड और देखिए। अब है 23/2³ इंटू 5 स्क्वायर है। ठीक है, दोनों के पावर्स इक्वल है, 2³ और 5 स्क्वायर के नहीं है इक्वल, तो हम लोग को दोनों के पावर्स इक्वल बनाना है। यहाँ पर पावर है 3 और यहाँ पर पावर है 2, तो हम लोग किससे मल्टीप्लाई करेंगे, हम लोग मल्टीप्लाई करेंगे 5 से। ठीक है, इंटू 5/5, तो ये क्या बन जाता, 23 इंटू 5/2³ इंटू 5³ बन गया। अब 23 5 क्या होता, 5 3 15, 5 2 10, 10 + 1 is 11, सो 115/2³ आपको आता, 2 2 4, 4 2 8 और 5³ आपको आता आंसर 125। करके देख लीजिए, 5 5 25, 25 5 125। ठीक है, 5 3 बार जब हम लोग लिखेंगे उसको हम लोग बोलते हैं 125। अब मल्टीप्लाई करिए 125 इंटू 8, 125 इंटू 8, 5 8 40, 8 2 16, 16 + 4 20, 8 1 8, 8 + 2 10, क्या आया, 1000 आया। सो 115/1000। अब फिर से जीरोज आएगा डिनोमिनेटर में, तो शिफ्ट हाउ मेनी जीरोज आर देयर, 3 जीरोज आर देयर, सो 1 2 3, क्या आया आंसर, 0.115। ठीक है, नेक्स्ट बिट देखिए, 7 to 1/3 स्क्वायर इंटू 5 स्क्वायर। यहाँ पर अगर आप देखेंगे तो डू यू हैव टू, यू डोंट हैव टू राइट ओवर हियर, तो आप मल्टीप्लाई करेंगे 2 स्क्वायर से। सबसे पहले अगर आप लोग कभी भी ऐसा वाला अगर फ्रैक्शन आप लोग को आया तो सबसे पहले ये 7 to 1/8 के प्राइम फैक्टराइजेशन निकालिए। ठीक है, तो मैं यहाँ पर मैं भी 7 to 1/8 का प्राइम फैक्टराइजेशन निकालूंगी। 2 3 6, 7 6 is 1 2, 2 6 12, 2 0 0, 1 8 आता, 2 9 18 आता हम लोग को, राइट। फिर उसके बाद 3 से जाता है, 3 1 3, 3 2 6, 3 0 0, 3 3 9, 3 4 12, 3 0 0, 3 1 3। अब 401 जो है वो प्राइम नंबर है, तो 401 400, याद रखिए आप लोग, 401 प्राइम नंबर है। तो हम लोग 7 to 1/8 कैसे लिख सकते, 2 इंटू 3 कितने बार है, 2 बार है ना, तो हम लोग 3 को कैसे लिख सकते, 3 स्क्वेयर इंटू 401। सो 7 to 1/8 क्या आया हम लोग को, 2 इंटू 3 स्क्वायर इंटू 401, वो हमारा न्यूमरेटर था, बाय 3 स्क्वायर इंटू 5 स्क्वायर। अब हम लोग जब प्राइम फैक्टराइजेशन निकाले तो निकालने का मतलब हम लोग को क्या ईजी हुई, यहाँ पे 3 स्क्वायर न्यूमरेटर में भी है और 3 स्क्वायर डिनोमिनेटर में भी है, तो हम लोग 3 स्क्वायर 1 3 स्क्वायर, 3 स्क्वायर 1 3 स्क्वायर, यानी 3 स्क्वायर हम लोग कैंसिल कर दे सकते हैं न्यूमरेटर और डिनोमिनेटर में से। तो ये फायदा है 7 to 1/8 का प्राइम फैक्टराइजेशन निकालने का। ठीक है, दैट इज वाई टेक आउट द प्राइम फैक्टराइजेशन एंड सी व्हेनेवर यू गेट सच टाइप ऑफ प्रॉब्लम जिसके अंदर आपके पास 5 के साथ कोई और नंबर है और वो बोल रहा है आपको कि थ्योरम यूज करके आपको करना है। ठीक है, तो व्हाट डू वी हैव हियर, 401 इंटू 2/5 स्क्वायर है। ठीक है, तो 2 इंटू 401/5 स्क्वायर बचा। अब हम लोग को मालूम जो भी हम लोग के पास डिनोमिनेटर में है 5, सेम थिंग वी हैव टू मल्टीप्लाई दैट बाय 2 पावर n, तो 2 स्क्वायर को न्यूमरेटर में मल्टीप्लाई करूँगी, 2 स्क्वायर को मैं डिनोमिनेटर में मल्टीप्लाई करूँगी। अब 401 इंटू 2 क्या होता, 401 इंटू 2 इज 2 1 2, 2 0 0, 4 8, 802 आया हम लोग को। अब 802 इंटू 2/5 स्क्वायर होता 25, 2 स्क्वायर होता 4, 802 इंटू 2 करके देखिए आप क्या आता, 802 इंटू 2, 2 2 4, 2 0 0, 2 8 16, 1604 आ रहा हम लोग को, एंड 25 4 100 आता। ठीक है, आर वी डूइंग एनी मिस्टेक ओवर हियर, अच्छा हियर वी हैव 2 स्क्वायर है तो ये 4 बन जाता ना, बिकॉज 2 स्क्वायर इज 4, तो फिर से हम लोग को इसको 2 से मल्टीप्लाई करना पड़ेगा, बिकॉज हम लोग 802 इंटू 2 करे थे ये। ठीक है, तो आप यहाँ पर 802 इंटू 4 करिए। ठीक है, 802 इंटू 4, 802 इंटू 4, 4 2 8, 4 0 0, 4 8 32, 3208 आ रहा आपको, तो 3208/25 4 क्या होता, 100 होता। अब 2 जीरोज है डिनोमिनेटर में, शिफ्टेड बाय 2 प्लेसेस 1 2, तो ये क्या होता हम लोग को आंसर क्या आता, 32.08। तो ये हो गया मेरा डेसिमल एक्सपेंशन ऑफ दिस नंबर 7 to 1/8 3 स्क्वायर इंटू 5 स्क्वायर। ठीक है, फिफ्थ बिट 143/110 है, ठीक है। तो अब आप क्या करिए, आपको यहाँ पे 110 का नहीं मेरा प्राइम फैक्टराइजेशन, 143 का भी नहीं है प्राइम फैक्टराइजेशन, तो आप निकाल कर देखिए क्या आ रहा। 110 का प्राइम फैक्टराइजेशन 2 5 10, 10 2 5 10, 11 55, 11 1 11। अब न्यूमरेटर 143 का भी प्राइम फैक्टराइजेशन निकालिए। याद रखिए 143 जो है 11 के टेबल में जाता, लास्ट टाइम भी बोली थी मैं आप लोगों को लास्ट वीडियो में। 11 1 11, 4 - 1 3 होता, 33 आता है यहाँ पे। 11 3 33, 13 1 13। तो हम लोग 143 को लिख सकते 11 × 13, और हम लोग 110 को लिख सकते 2 × 5 × 11 लिख सकते, ठीक है। अब यहाँ पे 11 11 1 11, 11 1 11, 11 कैंसिल हो जाता। 13/2 5 10 आता हम लोग को, एक 0 है तो शिफ्टेड बाय 1 प्लेस, सो इट बिकम्स 1.3। तो हम लोग 143/110 के डेसिमल फॉर्म में लिख सकते 1.3, ठीक है। यहाँ पर हम लोग को मल्टीप्लाई करने की ज़रूरत पड़ी ही नहीं कोई भी 2 और 5 से, क्यों? बिकॉज 2 का भी पावर क्या है 1 है, 5 का भी पावर 1 है, तो दोनों पावर्स इक्वल है, और ऑलरेडी 11 11 कैंसिल हो गया, तो डिनोमिनेटर डायरेक्टली 2 पावर n × 5 पावर m के फॉर्म में था, इसलिए हम लोग कुछ भी मल्टीप्लाई डिवाइड नहीं करें यहाँ पर, डायरेक्टली हम लोग को डेसिमल जो डिनोमिनेटर है 10 100 1000 10,000 ऐसे फॉर्म में आ गया, ठीक है। तो कर दिए हम लोग सॉल्व। Okay. See the fourth question. Express the following decimals in the form of p/q and write the prime factors of q. What do you observe? सॉरी, जो हम लोग का डेसिमल फॉर्म है उसको हम लोग को कन्वर्ट करना है p/q फॉर्म में, मतलब डेसिमल फॉर्म को रेशनल नंबर के फॉर्म में करना है। लास्ट क्वेश्चन में क्या करें आप, रेशनल नंबर को डेसिमल फॉर्म में करे थे, अब उल्टा करना है, डेसिमल फॉर्म को रेशनल नंबर के फॉर्म में लिखना है, और जो डिनोमिनेटर q है उसके प्राइम फैक्टर्स भी हम लोग को लिखना है, ठीक है। तो सबसे पहले 43.123 है, इजीली मैं 43.123 को p/q फॉर्म में कन्वर्ट कर सकती, कैसा? हम लोग को मालूम कि जहाँ पर भी डेसिमल पॉइंट है उसके बाद के प्लेसेस काउंट करना, तो डेसिमल पॉइंट के बाद कितने प्लेसेस है 1 2 3, तो किससे डिवाइड करूँगी मैं इसको 1000 से डिवाइड करूँगी, ठीक है। तो ये हो गया मेरा p/q फॉर्म, ठीक है। लेकिन it also told us that write the prime factors of q भी बोला था वो क्वेश्चन में, ठीक है, write the prime factors of q। तो अब फिर से आपको 1000 का प्राइम फैक्टराइजेशन निकालना पड़ेगा। 1000 का प्राइम फैक्टराइजेशन 2 5 10, 2 0 0, 2 0 0, 2 2 4, 5 - 4 is 1 0, 2 5 10, 2 0 0, 2 125 250, 5 2 10, 2 5 5 5 25, 5 5 25, 5 1 5। तो आपको मिला 43.123/1000 कैन बी रिटन एज 1232 क्यूब इंटू 5 भी कितने हैं 1235 है, सो 5 क्यूब। मतलब हम लोग के यहाँ पे प्राइम फैक्टर्स ऑफ क्यू आर व्हाट, प्राइम फैक्टर्स ऑफ क्यू आर 2 हाँ क्यूब एंड 5 क्यूब, या फिर हम लोग लिखेंगे प्राइम फैक्टर्स ऑफ क्यू आर 2 × 2 × 2 × 2 × 5 ऐसे लिखेंगे, ठीक है। 2 and 5 हमारे प्राइम फैक्टर्स हो गए यहाँ पर, 2 and 5 हमारे प्राइम फैक्टर्स हो गए यहाँ पर, ठीक है। और उन्हें और एक क्वेश्चन पूछा था हम लोग को कि क्या ऑब्जर्व करते हम लोग, तो हम लोग यहाँ पे बोलेंगे कि हम लोग ये ऑब्जर्व करते क्योंकि डिनोमिनेटर 2 पावर n × 5 पावर m में फॉर्म हो गया, इसका डेसिमल एक्सपेंशन क्या रहता, टर्मिनेटिंग डेसिमल एक्सपेंशन रहता, तो वो भी लिख देंगे हम लोग। ये ऑब्जर्व करें हम लोग, वी ऑब्जर्व दैट सिंस q इज इक्वल्स टू 2 पावर n × 5 पावर m फॉर्म, therefore for this it has a terminating decimal expansion, ये लिखेंगे हम लोग, ठीक है, terminating decimal expansion। अब आप देखिए नेक्स्ट बिट 0.201 201 है आपके पास, हम लोग इसको कैसे लिख सकते, 1 2 3 4 5 6 7 7 प्लेसेस पे शिफ्ट करना है, 1201 201/10 पावर 7 होता है ये, ठीक है, या फिर 1 2 3 4 5 6 7 7 लिख दी मैं, इट विल बी अ लॉन्ग प्रोसेस, 1 2 3 4 5 6 7, 2 5 10, 2 0 0, 2 0 0, 2 0 0, 2 0 0, 1 2 5 10 हो गया, 1 2 3 4 5 6, 1 2 3 4 5 6, again with 2 2 2s are 4, 5 - 4 is 1 0, 2 5s are 10, 1 2 3 4 5 5 zeros आते हैं यहाँ पे, 2 3 4 5। फिर से बी वेरी केयरफुल व्हेन यू डू प्राइम फैक्टराइजेशन है बिकॉज जीरोस बहुत ज़्यादा है, 2 1s are 2, 2 2s are 4, 5 minus 4 is 1 0, 2 5s are 10, 2 zeros are 0, 1 2 3 4, 4 zeros हो गए. Zeros कम होते जा रहे हैं as we go on dividing. 2 6 are 12, 2 2s are 4, 5 minus 4 is 1 0, 2 5s are 10, 2 zeros are 0, 2 zeros are 0, 2 zeros are 0. 2 3s are 6, 2 1s are 2, 2 2s are 4, 5 minus 4 is 1 0, 2 5s are 10, 2 zeros बच गए. फिर से 2 में करिए. 2 1s are 2, 3 minus 2 is 1 1, 2 5s are 10, 1 2 2, 2 1s are 2, 3 minus 2 is 1 1, 2 5s are 10, 1 2. एक मिनट. 2 1s are 2, 3 minus 2 is 1 1, yeah. 2 5s are 10, 1 2. 2 1s are 2, 3 minus 2 is 1 1, 2 5s are 10, 1 2, 2 6 are 12, 2 2s are 4, 5 minus 4 is 1 0, 2 5s are 10, 2 zeros are. ठीक है. 1 2 3 4 5 6 again with 2. ये था 2 7s are 14, 5 minus 4 is 1 6, 2 8s are 16, 2 1s are 2, 2 2s are 4, 5 minus 4 is 1 0, 2 5s are 10. Now do with 5. 5 1s are 5, 7 minus 5 is 2 8. ठीक है. 5 5s are 25, 3 1, 5 6 are 30, 5 zeros are 5 6 are 30, 1 2, 5 2s are 10, 5 1s are 5 आता आपको. Am I doing correctly? 5 1s are 5, 7 minus 5 is 2 8, 5 5s are 25, 3 1, 5 6 are 30, 1 2, 5 2s are 10, 2 5, 5 5s are 25. 5 आता है यहाँ पे. 5 3s are 15, 5 1s are 5, 6 minus 5 is 1 2, 5 2s are 10, 2 5, 5 5s are 25. 5 6 are 30, 1 2, 5 2s are 10, 2 5 5 5s are 25. 5 1s are 5, 6 minus 5 is 1, 6 minus 5 is 1, 2 5 2s are 10, 2 5 5 5s are 25. Again with 5, 5 2 25 अगर आपको रहता है आप लोगों को मालूम है तो 5 1s मतलब आपको 1 2 3 4 5 6 and again 5 with 5, 5 5s are 5 1s मतलब 7 5s आ रहे और 7 2s आ रहे. क्यों वैसा हो रहा? बिकॉज जितने जीरोज रहेंगे उतने 2 पावर और 5 पावर रहेंगे. ठीक है, याद रखिए ये बात. 7 2 7 5s आ रहे. ठीक है, तो मैं कैसे लिख सकती? 1 2 0 1 2 0 1 by 1 2 3 4 5 6 7 can be written as 1 2 0 1 2 0 1 by 2 7 into 5 power 7. We can write since q is equals to 2 power n into 5 power m form. Therefore, we observe that it has terminating decimal expansion. ठीक है.